All right. It says a manufacturing machine has a 7% defect rate. If 8 items are chosen at random, what is the probability that at least one will have a defect? So for all of the problems in this chapter, we're using the binomial PDF or binomial CDF. So we're looking here for the probability from 8 trials that at least one defect. So if I was to really write that out, I would say let X be the number of defects. We know the probability of X being greater than or equal to 1. So you could find the probability of 1 defect, the probability of 2 defects, 3, 4, 5, 6, 7, probability of 8 defects, add them all up. Or you can say, if I'm looking for the probability of at least one, what's the complement? What's the only other way this can play out? Well, like I said, this is the same as 1 minus the probability of no defects. X equals 0. Remember, X is the number of defects. This is just the using the complement rule, the rule of complements, okay? This is really easy to figure out. The probability of 0 defects, so that's a one specific case. So to find that, I'm going to use second distributions binomial PDF. I have 8 trials. A success would be here having a defect. So my success rate is 0.07. I'm looking for the probability of 0 defects. So I get 0.559581, but I want to know what 1 minus that is because this is my complement. So I do 1 minus. So that's where I get the 0.44041819033496. Okay. Next problem here. It says about 8% of the population has some genetic mutation. 900 people are randomly selected. Find the standard deviation for the number of people with the genetic mutation. So if you haven't done so yet, you need to go onto our Blackboard page, and under additional resources on our course materials page, there's a formula sheet. It has all the formulas you need. Let me see if I can pull that up. Oops. For this chapter. So it might take a little bit. Course materials. Go down to additional resources. And you're going to want to click the formula reference sheet. It's a Word document. Pop that up. Pray your computer doesn't blow up. And so here we have the binomial distribution. That's what we're using this whole chapter. Standard deviation of a binomial distribution is the square root of n times p times q. So here we have n equals 900. P is our success rate, which is 0.08. Q is just the complement of the success rate or the failure rate, 1 minus 0.08, which would be 0.92. So I'm just going to do the square root of 900 times 0.08 times 0.92. So we have square root 900 times 0.08 times 0.92. That's where we get the 8.13879, yada, yada, yada. Okay, that's just a formula from the formula sheet. Okay, question 40 says, assume that a procedure yields a binomial distribution. Of course, we're in chapter 4. 10 repeated trials use either the binomial probability formula or technology. We won't use Excel or StatDisk to find the probability of k equaling 6 given the probability success rate of 37 over 60. They just straightforward tell you, don't make it more complicated than you have to. Distributions, binomial PDF. We have 10 trials. My success rate, just plug it in as a fraction, 37 divided by 60. And I want to know the probability that k is 6. So I get 0.2493697. 4 decimal places will be 0.2494. Okay. All right. This says assume the procedure yields a binomial distribution. Of course, number of trials is 1,294. Success for one trial is 5/12. Find the mean. That's also from our formula sheet. Mean for a binomial is just going to be n times p. So it's n times p, 1294 times 5/12. That's 539.16 or 539.2. Standard deviation, that's the square root of n, 1294, times the success rate, which is 5/12. So I can do parentheses, 5/12. If you want to convert it to a decimal first, you can. And then times q. If p is 5/12, the chance of a failure is the rest, 7/12. Like that. So 17.73. Whoops. And then it says use the rule of thumb to find the minimum usual value, which is just mu times 2 theta, and the maximum usual value, which is mu plus 2 theta. Do 2 times this. This is, not theta. This is sigma. 2 times sigma. Theta is completely different. 2 times sigma, I get that. So then I'll take my mean, subtract it, take my mean, and add it. So this goes from 503.6975 to 574.6357. The weird thing is here, no matter what these decimals are, the lower bound, which is 503, I'm going to round down. So this is going to be 503 square brackets up to 574.6, round that, always round that up regardless of the decimal, up to 575. Okay, just follow this formula. Mu minus 2 sigma and mu plus 2 sigma. Okay. A coin is flipped 11 times. Find the probability that more than 6 flips turns up tails. Let's let x be the number of tails that show up. I want to find the probability that x is greater than 6. Well, what's the complement of that? Probability of x being less than or equal to 6. So if I want to find this probability, use the rule of complements and just take 1 minus the complement, which I can find in the calculator. You're going to have to do this whenever it asks you for more than some value. So what is the probability of x being less than or equal to 6? Well, now we're doing a binomial CDF because we're talking about less than or equal to some value. I have 11 trials. My success rate is 50%, and I'm looking for 6 or fewer. Enter one more time. Do not put that in as your answer. Luckily, they didn't even give you that option. We're going to do 1 minus that because I'm looking for the complement of that. So I get 0.274414. Just like that. And this is a long question, but not necessarily useful, any of this stuff. It says, assuming his suspicion that 10.2% of his customers buy a magazine, what is the probability that exactly 2 out of 14 buy a magazine? Exactly 2, that's binomial PDF, 14 customers, 10.2% chance of buying a magazine, or 0.102, probability of exactly 2. We get 0.26035. And that's your answer.